Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Dynamics. Dynamics basically it is a branch of mechanics. Basically, dynamics is the branch of mechanics. I am getting it in focus, bringing this in focus. So you can also read it carefully. Okay. So dynamic is the branch of mechanics basically concerned with the motion of bodies under the action of force. As I told you that in the previous in kinematics, we were studying that kinematic is the study of motion of the bodies without the reference of the forces. So here in the case of dynamics, remember that we are talking about the motion of the bodies, but under the action of forces. Those forces may be the push or pull, and these type of forces may be the weight or maybe the resistant forces. So what type of the forces, whatever the type of the forces it may be, so we have to discuss the motion of the body under the application of certain force. As you know that to set a body in motion, we need force. Okay. So we can also say that the dynamics refers to the branch of mechanics that deals with the movement of object and the forces that drive that movement. Okay. Well, so that the forces will also be discussed here. Whenever we are discussing the motion and there is a reference of force, so it means that we are studying dynamics. If we are only studying the motion like speed, velocity, acceleration without the reference of the forces, it means that is kinematics. Okay. Well, force, as you know that the definition of force in the primary classes or in middle classes, you might have learned that push or pull of on a body is called force. Here, something more will be added. A force may be considered as as any action that tends to produce motion, a change in motion, or a distortion to the body to which it is applied. Well, now let me discuss about this definition of force, that what is force. Okay. So, well, the force basically, as you know that if you are pushing a body or you are pulling a body, it means the force can set a body in motion. For example, this is a body, a block, and you are applying a force in this direction. It means this force can move this object. Let us have an example from the daily life. If you people are asked to push a car, so I think so you can very easily push a car. The car can be set in motion if it is standing or when okay. So if it is parked somewhere, so you may apply the force and you can move the car easily. So you are applying the force and you are moving the car. Okay, for those who are weaker, for them the car is very heavy to be moved. Okay, so let us take the example of toy car. Okay, so a toy car can be moved very easily. Okay, or I can take the example of this marker. I think so you people are powerful enough to move this marker. So if I apply a slight force from the right, so it is moving. Okay, my force is has brought this marker into motion. So if this marker is moving like this, I can also apply the force to change the direction of the motion of the marker. Okay, so force can move an object. Remember this, force can move an object or tends to move an object. For example, if you people are asked to apply the force only one person to move a huge bus, so you are applying the force, but the bus is not moving. It means the force is trying to move an object, but the object is not moving, although the force is applied. The force can also change the direction of the motion of an object. Remember this, for example, if someone in cricket throw a ball and so it is being thrown in the direction of the batsman, and when the batsman hits the ball goes in the opposite direction or in any other direction. So it means by the application of the force, the direction of the motion is also being changed. Okay, so with the help of the force, you can also change the direction of the motion of a body. In the same way, so let me enumerate the points. First of all, you can move a body. You can move a body. You can stop a body. For example, if a ball is coming towards you, you can stop the body. You can change the direction of motion. Change the direction of motion. Okay. Or you can tend to change the direction of motion. You can move or tends to move, mean you can move or you can try to move. You can stop or you can try to stop. For example, if a tennis ball is coming towards you, you can catch it and you can stop it as easily. But if a motorbike with a speed of 50 meter per second or 50 kilometer per hour is traveling towards you, and or a car is coming towards you with the same velocity, so it is not easier for you to stop the car, or almost it may be impossible. Okay, so change the direction of the motion. I have given you the example of changing the direction of the motion. For example, the bowler is throwing a ball towards the batsman, and the batsman hits the ball and changes the direction of the motion of the ball. Okay, well, so all these things, in other in addition to that, force can change the speed also. It can also change the speed of the body, speed of motion, speed of motion or speed of body. For example, if the car is moving with a certain velocity, you apply the force on the brake, and then it slows down with the help of the force of friction applied on the brakes. Okay, so force can also slow down the motion of the object. So all these things which force can do, which I have mentioned just now, we can say that force can produce an acceleration or tends to produce an acceleration. In nutshell, for all these things, I simply can say that force can produce or tends to produce acceleration. Please listen to my words very carefully, that instead of saying all these things which I mentioned before, can I say simply that force can produce or tends to produce acceleration in a body? Because you can see in the previous chapter you have studied that if you are applying a force on a body, if the body is moving, then there is an acceleration. There may be an acceleration. If the direction is changing, there is an acceleration. If the body is stopping, it means while stopping there will be an acceleration. So the force can produce or tends to produce acceleration in a body. Other than that, other than all these things, there's another thing which force can do: change the shape of the body. Change the shape. Force can also change the shape of an object. Now I am going to tell you about vectors. What are vectors? I told you that the vectors are those quantities in which we describe the directions. And I gave you the example of vectors, that displacement is a vector quantity, because when I am placing this pencil here and I'm displacing it in upward direction, so that I have mentioned the direction that I am mentioning. So these type of quantities are vector quantities in which I mentioned the direction. Okay, so velocity is a vector quantity, acceleration is a vector quantity. In the same way, force is a vector quantity. Force is a vector quantity. Sorry, vector. Force is a vector quantity. Unit of force. What is unit of force? unit of force is Newton. Okay, so now in the later classes, inshallah, we'll discuss that what is 1 Newton actually. You must be aware that if we are talking about weight is also a force, remember that weight is also a force. So the unit of weight will also be Newton. Remember this, because weight is also a force and the unit of weight is also Newton. And you know that what is the direction of weight? Weight is always directed towards the center of the earth. If I am taking like this is earth, then if a body is lying here above the ground, then its direction will be towards the direction of weight will be towards the earth, towards the center of the earth, towards the center of the earth. Remember this. Okay. Uh, Now I'm going to discuss that weight, because I told you that weight is also a force and its unit is Newton. Remember this, that whenever you people are asked that what is weight, so you will say that weight is a force which is always directed towards the center of earth. If somebody asks you that why it is a vector quantity, because whenever there is a force, there will be a direction. If you people are asked to apply the force, then you will be confused that in which direction you are going to apply the force. For example, if I place a block in the center of a table, for example, this is a block, and I ask you that apply the force on this block, then randomly you may apply the force, then I'll say that I didn't ask you that apply the force in that direction. So for the application of the force, I will have to mention you that apply the force towards right, towards left, towards upward direction or downward direction, etc., etc., or other direction I can mention. So whenever you are applying the force, the application of force will be with direction. So without the reference of direction, force cannot be applied. Remember this thing. Okay. Well, guys, now as I told you that we are going to discuss vectors, and in vectors, I told you that force is an example of vector. So with the reference of force, I am going to explain you that how the vectors are represented. Representation of vector. Uh, how the vectors are represented, because this representation of vector is very important, and with the help of this representation you will have to solve your problems. Representation of vectors. For example, I gave you the example of force. Say there is a force of 65 Newton applied towards east, towards east. So here I have mentioned that this is the force of 65 Newton, and you are going to show that this force is applied towards east. Remember this, if I am using the reference of east, west, south, or north, etc., then you must also give the reference of east, west, south, or north, etc. If I am not giving the reference of east, west, or south, etc., so you are not going to give these references. Okay, I'll give you the example in the uh, I mean examples. I will explain it, inshallah. So, well, now my problem is this, that force of 65 Newton, which is acting towards east, how I am going to draw this. Actually, the vectors are represented with a straight line. Vectors are represented with a straight line. To draw that straight line, one main thing you have to do, that you have to choose a proper scale. The scale which you are going to choose should be according to your size of your paper over which you are going to draw, because you can see that here I have a normal size of paper which you are using in printing or publishing, etc. So I will have to choose a normal type scale that my line can be drawn easily. So before drawing that, let me tell you some direction. This is north, as you know, this is west, this is east, and this is south. Now this force of 65 Newton is mentioned towards east. So first of all, scale. The first thing which you are going to do is you are choosing a scale. So choosing a scale, for example, one example I am giving you, you may also give me the rest of the example in the comment box. Well, for example, I am taking 10 Newton to 1 centimeter. This is my choice, that 10 Newton to 1 centimeter. So obviously, if I'm going to represent 65 Newton with the help of the in terms of centimeter, then what I'm going to do, 65 divided by 10 gives you 6.5 centimeter. So I chose the scale 10 Newton is equal to 1 centimeter. There is another example. For example, you can also choose 5 Newton 1 centimeter. So it can be the line of, say, you will have to 13 centimeter almost. Okay, so it's up to you that whatever the scale you are choosing. If I am choosing a bigger scale, for example, if I say that 1 Newton represent 1 centimeter, then you can see that the length of the paper is not 65 centimeter. So that will not be a proper scale according to which we can draw this vector on this piece of paper. Now how I am going to draw, I will have to draw the horizontal line, because I have to see that in which direction I am going to draw. I'm not going to draw a line like this because it will not be in the east direction. So what I am going to do, I will have to, after choosing the scale, I know that 65 Newton can be represented by 6.5 centimeter. So I will have to see that the direction of east is this. So I am going to draw the line equal to 6.5 centimeter. After drawing this line of 6.5 centimeter, what I am going to do, I will have to mention an arrow. Mention an arrow to show that it is towards east. I'm mentioning arrow here in between the two endpoints. Actually, I can also mention the arrow at the top of this line. But what is the problem? Because some students do not take it seriously, and while mentioning the arrow at the top, what they did, for example, I'm showing you an example of a student who is not carefully drawing. For example, he has drawn the line like this, 6.5 centimeter, and he mentioned the arrow like this. Okay, so it is not the correct way of drawing. That is why I suggest you that if you have drawn a line according to the chosen scale, it's better to mention the arrow like this in between these 2 points anywhere. Okay, so this arrow is very important. Remember this. If you have not mentioned this arrow, it means you are not mentioning the direction. Okay, another thing, if this arrow is from west to east, so this will be the tail, this will be considered as tail, and this will be the head. So this is tail and this is head. Remember this. uh, from the starting point will be the tail and the ending point will be the head of a given vector. Let us choose another scale. If I am taking that 5 Newton to 1 centimeter, so here obviously I will have to draw the line of 13 centimeter, because 65 divided by 5 gives you 13 centimeter. So 65 will be represented with the help of 13 sorry 13 centimeter length. Let me make it accurate length uh, here. Okay, so after doing this, this is 13 centimeter length. So anywhere on the line you can mention an arrow, but you must mention the arrow. Okay, more than two forces. For more than two forces, more than two forces. Say this is a block at which one force is acting in this direction. Say this is 500 Newton force, and one force is applied in this direction. Say this is 600 Newton force. Now these two forces are mentioned on the piece of paper. Now how you are going to show these forces? With the help of the vector diagram. These two forces are applied. Now here you can see that I have not mentioned any east, west, south or north. So you are not going to give the reference of east, west, south of north, because in the question that reference is not given. Remember this. If that reference of directions is given, then according to that you have to give. First of all, as I told you, that you have to choose a scale. So what the scale you are going to choose? Suppose I am taking that 100 Newton to 1 centimeter. Okay, so this scale, I think so it is easier for me, and these two forces are making an angle of 90 degrees with each other. So obviously I will have to mention these forces according to the angle given. As I told you that in the beginning, these two forces are making an angle of 90 degrees. So first of all, I'm going to draw the force of 500 Newton. So 500 Newton force will be mentioned with the help of 5 centimeter line, and 600 Newton force will be mentioned with the help of 6 centimeter line, and the angle between these two forces will be of 90 degrees. So what is the best way of drawing this? As if somebody asking you that what is the resultant of these two forces, let us have an example on the resultant of these two forces. Say I have an eraser here. Under the application of two forces, what is going with this eraser? One force is applied here and other is applying here. This force is greater, the pencil force is smaller. So these two forces, the eraser is going in this direction. Somewhere here it is going. So I'm going to find out the resultant of these two forces which are applied on this. Okay. So let us see that how we are going to discuss this resultant, how we are going to draw the resultant of these two forces. First of all, I am going to draw whatever the force you can take first. If I'm going to take the force of 500 Newton first, so I am going to draw the line of 5 centimeter. Here you can see that I have drawn the line of 5 centimeter because it is in the mentioned direction. So you will have also have to mention the direction like this. This is 5 centimeter line. In the beginning, I told you that this end is called the tail. This is called tail, and this is called head. This is head. So the head of this vector will be joined with the tail of the second vector. This is the second vector which is in upward direction. Okay, so its tail will be joined with the head of the first drawn vector, whatever the vector you have taken as first. So here in this direction, making an angle of 90 degrees, you will have to draw the line of 6 centimeter. This is 6 centimeter line. So in this way, I have mentioned these two forces. So inshallah, next we'll discuss that how the class is going to be over now. Yeah, yes, we can draw it down. No, we cannot draw it downwards because it is in upward direction. You can see that it's in upward direction. You will have to take care of the direction. Please take care of the direction. We will discuss in detail, inshallah, in the next class. Okay. I think class is going to finish in few seconds.